Hi guys. So this time we're going to be working with dividing decimals. Dividing decimals. Let me get this. Okay, so when we divide with decimals, the first thing, the most important thing we need to keep in mind is that you cannot actually divide by a decimal. So you can divide into a decimal. You can make a decimal by division, but you cannot divide by a decimal. So when we have things set up like this, 36.5 divided by 5. I can do that. That's perfectly fine. I'm not going to have any problems there. I can simply set it up as 5 into 36.5, and I can just do that. Yes, there is a decimal, but it is inside, not outside, so I can just divide it over. If I have this, however, 33.4 divided by 1.2, I reset that up as 1 2/10 into 33 4/10. I cannot currently divide it that way. I have to change it first before I can start dividing. So our rule is, number one, first thing you need to remember is all, let's see, what is that called? Divisors have to be whole numbers. You cannot divide by a decimal. You cannot divide by a decimal. Just a second. Number two, if, as in this case, they're saying, yes, you're supposed to divide by a decimal if the divisor is a decimal. Move the decimal point as many places right as you have to make it a whole number. So in this particular case, I only have to move it once to make it a whole number. And then it's no longer a 1 2/10, it is now a 12. Once I've done that, however, number three is move the decimal of the dividend, that's the inside number, the same number of places. So you may end up with a dividend that ends up being a whole number, like we end up here. You might end up in a situation where you have a let's say that I have 0.05 into 1 6/10. I have to move the outside 1 2 times. I have to move the inside 1 2 times. So I actually end up having to add on a 0 so I can make it 160. So it's 5 into 160 now, okay? This is the first thing that you do. Every single time you have to move the decimal if the decimal is not in a usable place. Number 4 is divide. Okay, so number 4 is divide. So let's try some division problems and see what we can get. Okay, first division problem. Actually, you know what? I'm going to show you this. So let's go back to the one that we had before. 36.5 divided over 5. So 36 and 5/10 fits. So I can write it as a fraction. All fractions are actually division. The bottom number goes on the outside. The top number goes on the inside. I do not need to move the decimal point because this is already a whole number. So I move my decimal point here. Okay? That's how we work with division. The decimal point goes directly above where it is inside the dividend. Okay? On the inside number, it just goes straight up above that. So then I ask myself, can I take 5 into 3? Nope, can't take 5 into 3. Can I take 5 into 36? Yes, I can. How many times? 5 times what is about 36? 5 times 7 gives us 35. 6 minus 5, 1. Bring down the 5. 5 goes into 15 how many times? 3. Because 5 times 3 is 15. And that gives us a 0 as the end. And so we are done, and our answer is 7/10. Let's do a different one. Let's do, if I have the problem set up this way. 2 and 442 hundredths divided by 2. If I set up the problem this way, this is what happens. That number, the second number, is still on the outside. The 2 and 42 hundredths is still on the inside. Okay? So this is how we set this one up. That is already a whole number. I do not need to move the decimal point. I simply put the decimal point above. 2 goes into 2 how many times? 1, because 1 times 2 is 2. 2 minus 2 is 0. Bring down the 4. 2 goes into 4 how many times? 2, because 2 times 2 is 4. 4 minus 4 is 0. Bring down the 2. 2 goes into 2 how many times? 1, because 2 times 1 is 2. 2 minus 2 is 0. So our answer ends up becoming 1 and 21 hundredths. Let's try it this way. If I have a problem that looks like this, let's go with 445 and 24 hundredths divided by 3. Okay. The issue is with multiplication and addition and subtraction, honestly. I can just pick any number and we'll do just fine with it. With division, that is occasionally not the case, and I'm trying to get ones where we aren't going to end up massively expanding out into the ether and never actually reaching an answer. So that's why we're dividing by things like 5 and 3 and 2 and that sort of thing, because I know what those numbers do. I know how those numbers work. 3 into 45. Oh, sorry. It was supposed to be that line this time. So if we have that line there, the 3 is still on the bottom. It's supposed to be a sideways fraction. Okay, so that's the line that we're using. And 24 hundredths. Okay, again, our outside number does not have a decimal, so we do not have to move it. We simply place the decimal on the inside. Does 3 go into 4? Yes, it does. How many times? 1. 1 times 3 is 3. 4 minus 3 is 1. Bring down the 5. Does 3 go into 15? Yes, it does. 3 times what is 15? 5. 3 times 5 is 15. 15 minus 15 is 0. Bring down the 2. Does 3 go into 2? No, it does not. So we put a 0 up there and bring down the 4. Does 3 go into 24? Yes, it does. How many times? 8, because 8 times 3 is 24. And then we can subtract out our 0. Very good. Now, those are all with us not having to move the decimal point at all. Let's try some where we do have to move the decimal point. So let's do 16 and 5/100 divided by 3/10. 16 5/100 divided by 3/10. Okay, so the 3/10 goes on the outside. The 16 and 5/100 goes on the inside. I cannot divide that the way that it currently is. I have to move the decimal point. So I move it in 1. So I move it in 1 here. And that is our new decimal point. So now I'm dividing everything by 3. Does 3 go into 1? No. How about does 3 go into 16? Yes, it does. 3 times 5 gives us 15. 6 minus 5 is 1. 1 minus 1 is 0. Bring down the 0. 3 goes into 10. How many times? 9. Oh, no, it doesn't. It goes in 3 times because 3 times 3 is 9. 10 minus 9 is 1. Bring down the 5. 3 goes into 15 5 times, because 3 times 5 is 15. Remember, we can always go back and forth with our multiplication and division. They're opposites of each other. So we use them a lot with each other in order to solve our problems. Let's try this one. Let me see. If I have a 17.5 divided by a 0.25. Yeah, we can do this. Okay. So I'm going to rewrite this. This is our outside number. Goes into 17 and 5/10. So 25 hundredths into 17 and 5/10. I cannot do that. So I need to move it 1, 2 on the outside, 1, 2 on the inside. I need to give myself another 0. That's going to be where our decimal point is, okay? We may very well not even need a decimal point in this one, but that's where the decimal point ends up at anyway. So I ask myself, does 25 go into 17? No, it doesn't. So then I think to myself, okay, so 25, well, that's about 30. So how many times does 30 go into 175? How many times does 3 go into 17? I don't really need to worry about the 0 at the moment. I just need to worry about the 3. How many times would 3 go into 17? Let's see if that works. 3 goes into 17 5 times. So let's see what happens if I multiply by 5. 5 times 5 is 25. 5 times 2 is 10 plus 2 is 12. 125. No, I don't think that's going to be good enough. I don't think that's going to be high enough. 25 times, what should I try now? So if I rounded down instead, if I did this by 20 and then I did 17 goes, how many times, how many 2's can I put into 17? That would give me 6. 6 times 5 is 30. 6 times 2 is 12 plus 3, 15. Wait, 150. Wait, I did that wrong. Would have gone in 8 times, wouldn't it have? Because 2 times 8 is, no. Yeah, 2 times 8 is 16. I was wondering how I ended up with an even smaller number than I started with. Oh boy. Okay. Well, it looks like we only needed a little bit higher, so how about we just do the 7? 25 times 7. 5 times 7 is 35. 7 times 2 is 14 plus 3, 75, 117. So it ends up being 175, which will put us at a 7 for 175. And then we bring down the 0. And we end up with 70. So in order to get there, we would need 70 of the 25 hundredths. Okay? There are 2 sheets underneath this one. One where you're dividing by the whole numbers, and one where you're dividing by the decimals. All of them are set up in this format. All right, most ones where you end up getting it from a computer are set up in this format because computers really don't like this and they really don't like this. So normally you will see on a computer it's set up this way. Okay, talk to you later. Bye.